Welcome back. I hope you are excited to learn about more series circuits. Here's your quick joke. Why did the book join the police force? It wanted to go undercover. Mr. McBride, again, is very happy to hear these jokes. Okay, so what we're doing today is I'd like to, before you start this, make sure that you have your notes, make sure that you have your green sheet. Again, I'm using my white sheet, and also a calculator would be helpful for today. So what we're going to do is let me give you the definition of what a series circuit is. This is a circuit in which all current runs through all elements. A circuit in which all current runs through all elements. Now, have you ever watched the movie Christmas Vacation, where he puts all the million lights on the house and then he goes to plug it in and it doesn't work? The reason why that happens is because they used to make Christmas lights in series circuit. So if one bulb went out, the whole thing wouldn't work, okay? Because the current runs through all the elements, so if one element is broken or bad, then none of them are going to work. But they've since changed it, and they've made them so they're a parallel circuit, which allows them to work in case one light doesn't light, okay? Your house is also wired in parallel. The reason why that is because can you imagine if one thing wasn't turned on, your whole house wouldn't work? Okay, that doesn't make any sense either. So a series circuit is sort of something that we use for physics, but not necessarily something that you see a lot in your real life. Okay. Now let's write some equations. The first equation that I want to write is the easiest, which just says that the total current, which I call IT, is equal to the current that runs through the first resistor, is equal to the current that runs through the second resistor, is equal to the current that runs through the third resistor, and so on, which just tells you that in a series circuit, the current is the same. Okay, the second one that we talked about in our last video was the voltage. The total voltage, or the voltage from the battery, okay, it's going to add up. Remember we said the voltage through resistor 1 plus the voltage through resistor 2 plus the voltage through resistor 3. Okay, remember that like 1.5 plus 3 plus 4.5 gave us 9. All the voltages add up to get the total voltage. Okay, I'm going to add another one, and this one is called REQ. Okay, now just to make things difficult here, this EQ is sort of the same thing as the total. The EQ stands for equivalent resistance. And what this is saying is if we took one resistor and replaced all of the resistors in there, it would act the same. Now, why would you do this? Well, because you're trying to save money, right? So think about the circuit that we set up in the last video. You wouldn't use 3 resistors there, it would be expensive. You would just want one resistor that would do the same thing. So you could find the equivalent resistance, or how could I replace all 3 resistors with that same one so it does the same thing? Okay, now the equivalent resistance is going to add up. And the last one is this one that we're going to use for all of these. Remember Ohm's law, that V equals IR? Okay, well the same is true here, where we can say that the total voltage is equal to the total current times the equivalent resistance. So we're just taking and sort of making this, we're adding some subscripts here. So this is Ohm's law again, just a little bit different. Okay, now this is what I want you to write on your green sheet. I'm sort of running out of room here. This is the last thing that we have to write. I'm gonna make a table, okay? So actually, let's make a table here of, this is series resistors, and this is parallel resistors. So this is not the last thing you'll have to write. Okay, so in series, I'm gonna add a little line here so you know that there's a difference. And I'm just gonna rewrite these 4 equations that I just wrote. Again, that the total current is equal to the current through each piece. And I'm going to write down that the total voltage adds up. And this total resistance or equivalent resistance is equal to the resistance through each piece. And last but not least, my version of Ohm's law that adds TT and EQ. Again, V equals IR, but I'm just adding these subscripts, okay? So we'll keep this. And again, for those of you who are wondering, we're gonna make one more table like this below here, okay? All right, so let's start by drawing a series circuit. This says, draw a series circuit with 3 resistors, a battery, an ammeter measuring the total current, and the voltmeter measuring the voltage of one resistor. Please pause the video now and try to do this on your own. Check with me when you're done. Okay, so here's my ammeter measuring the total current. Now, true story is that the current is the same throughout, so it doesn't really matter where you put this, right? I've got my 3 resistors, and I need a voltmeter measuring the voltage of one resistor. Here's my voltmeter hugging this resistor. You really could have put it on any resistor, but here we go. All right, so let's start with some sample problems. I've got 3 sample problems, and then I've got some sample problems for you to try on a Google form today. So first thing we're going to do is it wants to calculate the total current in this circuit. Now when I look at this circuit, what I see here is 12 volts. And I'm also saying to myself, this is the voltage of the battery, so this must be the total voltage. And it's also telling me that the resistance here is 6 ohms, okay? So this is actually also the total resistance, or in this case, this one is REQ, because there's only one resistor, okay? So if you were to do this and we wanted to find the total current, which we know is IT, we're gonna come back up here and look at our equations. There's 2 equations that have IT in there. This one or that one? Which one do you think we should use? I hope you said that one, because we don't have any of the other current values, so we can't use that one. So we're gonna use our version of V equals IR. So we've got VT equals IT times REQ. Or we've got that 12 equals IT times 6. Or doing this complicated math, we see that the total current is 2 amps. All right, you ready to kick it up a notch? Here we go. This one wants to know what is the voltage across resistor 1 and what is the total current in the circuit? All right, so let's start with this one. What is the voltage across resistor 1? So what do we have here? Well, what is this 10 volts here? Hopefully you're saying to yourself, aha, this is the total voltage because it is the voltage that's read by the battery, okay? Next, I want to know what is this voltage. So that's really the voltage in one piece. Okay, so what equation could I come up here and use if I wanted the voltage in one piece? I'm thinking this one. So we should be able to say that VT equals V1 plus V2. Okay, or that the total voltage in this case is 10. We want to know what the voltage in resistor 1 is. And down here, we have what the voltage in resistor 2 is, which in this case is 4. Okay, so if you do this math here, we should be able to figure out that the voltage in resistor 1 is 6 volts. Okay, not bad. Now, let's find the total current in the circuit. There's a bunch of different ways to do this. I'm going to show you one way, but if you do it a different way, then just know that's okay too. All right, so how do I find the total current in the circuit? So I go back up here and I say, all right, there's this equation or that equation to find the total current. We're going to use this equation right now. And we're going to say, all right, VT equals IT times REQ. The good news is that we already have the total voltage. We know that this is 10. Okay? We want to find the total current. Our problem is that we don't have this REQ, or equivalent resistance. We can find the equivalent resistance by adding up the resistor values. Okay? So I'm going to come up here because I'm running out of room. So REQ equals R1 plus R2. Well, the resistance value of this is 6. And the resistance value of this is 4. So this is going to give us an REQ of 10. Or I put 10 in there. And then I should find that IT is equal to 1 amp. Again, you could have done this a different way, so don't worry if you didn't do it the same way as I did. All right, flipping the page here for a second. I got one more problem for you, and then I'm going to ask you to try some on your own. Or if you think you're ready, read this problem and try it on your own anyways. This particular problem shows me a series circuit that has 3 resistors. It has 2 questions here. What is the equivalent resistance in the circuit? And what is the total current? So what I'd like you to do is go ahead and pause this video and see if you can try that on your own. If you need some help, feel free to go along with me now. Okay, so the first thing we're doing is we're looking for our equivalent resistance. So if we go back to our previous page, how do I find the equivalent resistance? Well, there's really 2 formulas. I could use this one or this one, okay? But I don't have the total voltage or total current yet, so I think I'm going to use this one here. So I'm going to start with the fact that REQ is equal to R1 plus R2 plus R3, okay? Or I'm going to take 5 plus 10 plus 15, and I'm going to be lazy and not show my work here, and I'm going to get that this is equal to 30 ohms. And now when I'm looking for the total current in the circuit, if I look back at my formulas here, there's really these 2 equations to find the total current. This one or that one. So hopefully you're saying to yourself, we don't know the current in any of these pieces, so that's probably not a good choice. But we do know the total voltage, right? Because we have the voltage of the battery. In this case, hopefully you can read this, that it is 45 volts. We just calculated REQ, and then we're finding IT. Think like a physics teacher too. If I just asked you to find REQ, likely I want you to use the equation that has both IT and REQ in there. Okay, so if we use that VT equals IT times REQ, we get here, friends, that 45 is equal to IT times 30, okay? Or that we get that IT is equal to 1.5 amps. All right, have a wonderful weekend. I will be on Meet on Thursday between 3:30 and 4:30 if you have any questions. Bye, friends.